welcome to our lesson physics today. Today we want to look at a topic called radioactivity. Radioactivity, I believe, is a topic that you've come across at one point or another, especially in chemistry. So whatever we are going to do here probably is a repetition or revision of whatever you have already done. So we are going to have very little addition on top of what you have covered in chemistry. That is something on radiation detectors. Otherwise, we just go through what you have already covered for purposes of this subject. So radioactivity in itself, you define it as the spontaneous disintegration of the nucleus of an unstable atom to emit radiations. Meaning that there are atoms that normally their nucleus disintegrates into other particles, and the process they emit radiations or particles. So that process is called radioactivity. It is a spontaneous process, meaning it is something that takes place on its own. It occurs naturally without external factors coming in. So to explain more, we need to know about the structure of an atom. We know very well that an atom has that central part that we call the nucleus, and the nucleus is surrounded by an orbit called energy levels. On those energy levels we have electrons that move around. Now nucleus in itself has two particles, that is the protons, which will be represented by letter P, and neutrons. We have already learned earlier in this subject that electrons are negatively charged, protons are positively charged, then neutrons have zero charge. It means that because protons and neutrons are in the nucleus, they are held together by an energy called nuclear energy. And because proton plus neutron will have a resultant positive charge, it means that the nucleus is positively charged. Therefore, there is a force that will always try to attract electrons towards the nucleus and maintaining them in that circular orbit or energy level. As we have learned, that force is now what maintains the electrons along those energy levels. Now, there are other things that we may need to define about an atom. We start with this term called atomic number, which we represent by letter Z. Atomic number definitely is the number of protons in the nucleus of an atom. The number of protons. So meaning atomic number is just equal to the number of protons. We represent protons with P, but the atomic number will call it, or we represent it with the letter Z. Then we have mass number. Mass number is the sum of protons and neutrons. When you take proton plus neutrons, you end up with what we call mass number. Then, apart from that, we also have something called an isotope. An isotope is actually an atom, or sometimes call them isotopes, atoms that have the same atomic number but different mass numbers. They are atoms that have the same atomic numbers but different mass numbers. For example, we have carbon 12 and carbon 14. We normally use the letters there to distinguish them because the mass number will be the same but the atomic numbers will be different. Carbon, we know, is number 8. So it means that carbon will just have the same atomic number, the same mass number, but atomic number here will have 14. Yeah, so that makes it what we call an isotope. We have another thing, and this time we'll use it mostly in this topic, called nuclide. Nuclide here implies atoms that have, it is a group of atoms that have same mass numbers and same atomic numbers, meaning Z and A are equal. We call them nuclides. Now, in these nuclides, sometimes you find that you find that protons are not equal to neutrons. So nuclides have same protons. The number of protons equal to the number of neutrons. So in this case, sometimes you find neutrons are not equal to protons. And when neutrons are not equal to protons, what happens? We say that this particular nuclide or atom is unstable. And we know anything that is unstable will always try to achieve stability, will try to become stable. Yeah. So the process in which an unstable nuclide tries to become stable, will be defining it as nuclear stability. But then, sorry, radioactive decay. But then before we look at that, we have two types of nuclides. We have stable nuclides, that is where proton and neutrons are equal. That is the ratio of protons to the number of neutrons is 1 to 1. That is, protons are equal to neutrons. That one we say that that kind of nuclide is stable. But in a case whereby the protons are not equal to neutrons, we say that is an unstable. And in most cases, an unstable nuclide is a nuclide whereby the number of neutrons are more than the number of protons. When the number of nuclides are more than the number of protons, we call that an unstable nuclide. And an unstable nuclide will try to achieve stability. And how does it achieve stability? It achieves stability by undergoing a process that we will call radioactive decay. So, what is a radioactive decay? And don't confuse this with the reactivity. Sometimes students take it as that radioactivity and radioactive decay are the same thing. We define radioactive decay as the process by which the nucleus of an unstable nuclide disintegrates in order to become stable by emitting energy. The process by which the nucleus of an unstable nuclide disintegrates to become stable by emitting energy. In the process, apart from emitting energy, it can also emit particles. So we have three things that come out during this radioactive decay: emission of alpha particles, emission of beta particles, or emission of gamma radiations. So it means we have three types of radioactive decay. We have alpha decay, which we represent with the symbol alpha, the Greek letter alpha. Then we have beta decay, we represent it with the symbol beta. Then gamma radiation, we represent with the symbol gamma. So we want to look at these types of decays one by one. We start with alpha decay. When a nuclide, an unstable nuclide, disintegrates by emitting alpha decay, what happens? Alpha decay in itself is an helium atom. Alpha particle is an helium atom. Helium, the atom is represented like this. It has atomic number 4 and mass number 2. So it is represented like that. Yeah. So the mass number will decrease by 4 and the atomic number decreases by 2. So if we represent it in form of what we call radioactive decay equation, or simply a decay equation, you assume you have an atom X whose mass number is A and atomic number is Z. It decays by emitting alpha particles, so we present with an arrow. Then on top of that arrow we write alpha, the symbol. So it will disintegrate into an atom Y. So the mass number reduces by 4. So A, which was here A, now if it reduces by 4, we subtract 4. While the atomic number reduces by 2. So Z minus 2. Plus, we include the helium atom. This atom that disintegrates into Y, this atom X, we call it the parent nuclide. The one that it produces is called the daughter nuclide. Then the alpha particle emitted is just helium there. So in many cases, when writing the decay equation, we have to write the parent nuclide on one side, then the daughter and the particle emitted on the right hand side. And the atomic numbers of the parent should be equal to the atomic number of this should be equal to the sum of the atomic number of the daughter plus the atomic number of the particle emitted, in this case alpha. So in this case, this Z should be equal to Z minus 2 plus 2. Mathematically that is equal. The same would apply to the mass numbers. The mass number here must be equal to, of the parent, must be equal to the mass number, sum of the mass number of the daughter plus the particle emitted. Yeah, so we have now concluded that atomic number here must be equal to the atomic number of the daughter and the particle emitted, mass number the same. So generally that's what it involves when we talk about alpha decay. So in our next lesson we look at the other two types of radiations or radioactive decay particles emitted. Thank you.